What if a star in our galaxy, just 1,470 light-years away, started blinking out without warning? Not once, not twice, but over and over, losing up to 22% of its light in just a few days. No explosion, no planet transit, just darkness, and no one, not even NASA, can explain why. In 2015, data from the Kepler Space Telescope revealed something no astronomer had seen before. A star, KIC 8462852, now known as Tabby's star, was dimming in massive, unpredictable ways. The dips didn't follow any pattern, they weren't symmetrical, and they weren't caused by any object we've ever observed. Scientists scrambled for answers. Dust? Comets? A shattered planet? But then came a hypothesis so bold it sent shockwaves through the scientific community. What if an advanced alien civilization built a megastructure around their star, a real-life Dyson Sphere, blocking its light as it harvests energy from the sun itself? In this video, we'll explore the top 5 theories behind Tabby's star, from plausible science to the edge of the unknown. Stay until the end, because the wildest idea might also be the one that fits best. Tabby's star, officially named KIC 8462852, is one of the most puzzling astronomical discoveries of the 21st century. Its unpredictable dips in brightness have defied every conventional explanation, and to this day, scientists remain divided. In this section, we'll explore the top 5 most discussed theories behind this strange behavior, each one more intriguing than the last. If you find these theories as mind-bending as we do, don't forget to like this video and subscribe to the channel. We've got even more mysteries from the cosmos coming up. Top 5. A giant swarm of comets. The first major theory scientists explored was the idea of a massive swarm of comets orbiting Tabby's star. This explanation came shortly after the Kepler Space Telescope data revealed the star's bizarre dimming pattern. The idea goes like this. Perhaps a nearby star passed close enough to Tabby's star to disrupt a distant cloud of icy comets. Those comets, now gravitationally unmoored, fell inward and formed a swarm in a loose orbit around the star. If enough of them crossed our line of sight, they might explain the erratic dips in brightness. At first, this theory offered a plausible natural explanation. Comets can release dust and gases that obscure light. And if the swarm were thick enough, it could cause uneven asymmetric dimming, just like Kepler saw. But quickly, the math began to unravel the idea. To block 22% of the star's light, the comet cloud would need to contain thousands, if not millions, of objects, each dozens of kilometers wide. That's far more than what exists in our solar system's Oort cloud. Furthermore, comets warm up as they approach a star, emitting infrared radiation. Instruments like the Spitzer Space Telescope and WISE found no trace of such heat near Tabby's star. If the comet cloud were real, it should be glowing in the infrared. It isn't. Even the theory's own authors, like Dr. Jason Wright, admitted it was a stretch, a placeholder for something until better data arrived. But for a time, this was the best anyone could offer. As observational campaigns ramped up and the flaws in the comet model became clear, scientists moved to the next potential culprit: dust. Top 4. Interstellar dust or debris. The universe is dusty. Between stars, clouds of microscopic particles drift for millions of years. It's not unusual for dust to obscure starlight. We see this across galaxies. So what if Tabby's star is simply sitting behind an unusually thick or clumpy cloud of interstellar dust? This explanation gained traction because it was less dramatic than invoking aliens or shattered planets. Dust can block light in complex ways, and some proposed that long-term dimming could be explained by a slow buildup of debris from ancient stellar events. Dust also helps explain asymmetrical dips. Different density pockets could cause brightness to fall sharply and return slowly, just like the Kepler data shows. But again, the science pushed back. Dust typically scatters shorter wavelengths, meaning it dims blue light more than red. Yet Tabby's star dims evenly across all wavelengths. That's not what we'd expect if dust was the cause. Even worse, like comets, dust emits infrared radiation when warmed. But again, no excess infrared signal was detected near the star. If dust was there, it was either extremely cold or non-existent. There's also the problem of origin. No nearby stars or supernovae have been identified that could have dumped this much dust into Tabby's neighborhood. The dust would need to be local, massive, and invisible. That combination didn't sit well with astrophysicists. While still technically possible, the dust hypothesis fails in critical observational tests. With natural explanations slipping away, some researchers began asking more radical questions, like, what if something was destroyed? Top 3. A shattered planet or moon? Let's imagine a world, a massive rocky planet or moon, that once orbited Tabby's star. Over time, gravitational forces drew it too close. It passed the Roche limit, the point where tidal forces rip a celestial body apart. What's left behind? A ring of debris, perhaps dense enough to block starlight. This idea has precedent. Around white dwarfs and other stars, astronomers have observed debris disks, remnants of destroyed planets. These disks cause irregular dimming. Could something similar be happening here? Models of planetary breakup suggest the debris field would not be uniform. Clumps of fragments could pass in and out of our line of sight, explaining why the dips are irregular and don't follow orbital patterns. Moreover, this theory may help explain the long-term dimming trend detected in archival images. If the debris is slowly spiraling inward or dispersing, it might cause the star to dim gradually over decades. But, yet again, challenges appear. A destroyed planet would likely leave chemical fingerprints in the star's spectrum, signs of iron, magnesium, or silicates. Tabby's star doesn't show these in excess. Most debris rings settle into regular orbits. Tabby's dips aren't periodic. Still, many scientists find this theory compelling because it explains both short-term and long-term anomalies in a single catastrophic event. The image of a planetary system collapsing in slow motion is both tragic and profound. But the next idea takes the mystery one level deeper, into uncharted territory. Top 2. A new class of variable star. When all traditional explanations fall short, we're left with an unsettling possibility. Maybe Tabby's star is something entirely new. What if we're not looking at dust, comets, or planetary debris, but at a new type of star we've never encountered before? Astronomy has a long history of being surprised. In the 1960s, pulsars were detected as rapidly pulsing radio sources, so regular, in fact, that some scientists joked they were signals from aliens and nicknamed them LGM, Little Green Men. Quasars, too, were once mysterious and unclassifiable, appearing as star-like objects with bizarre spectral lines. Only later did we realize they were the intensely energetic cores of distant galaxies. Could Tabby's star be the next revelation? The hypothesis here is that Tabby's star might be undergoing a rare or never-before-seen phase of stellar evolution. Some suggest it might be an unusually active F-type star with internal magnetic changes. Others propose interactions with an internal reservoir of material or even large-scale convection events within the star's outer layers. The appeal of this theory is its grounding in natural processes. It doesn't require external dust, alien technology, or massive collisions. It challenges us to expand our models of how stars behave. However, this idea is difficult to test. Most known variable stars exhibit clear, repeatable patterns. They change in brightness predictably over days, weeks, or months. Tabby's star, by contrast, is erratic. Its dips have no clear periodicity. Some are shallow, some are deep. Some last hours, others last weeks. And there's no accompanying signal in other wavelengths. No X-ray bursts, no gamma-ray flashes, no flares. Additionally, despite years of monitoring, astronomers have not found any other star in our galaxy exhibiting the same pattern of irregular dimming. If this is a new stellar phenomenon, it appears to be uniquely rare, which in science raises red flags. A phenomenon seen only once is hard to distinguish from a misinterpretation. Still, the new class of star theory remains scientifically attractive because it pushes the boundaries of what we know, without stepping into speculation about alien life. It invites further observation and challenges astrophysicists to refine their models. But what if Tabby's star really is unique? Because it isn't natural at all. Top 1. An alien megastructure, Dyson Sphere. Of all the theories surrounding Tabby's star, none has captured the public imagination more than this. What if the star is being partially blocked by an alien megastructure? This idea is rooted in a concept proposed by physicist Freeman Dyson in 1960. He theorized that a sufficiently advanced civilization might seek to capture more energy from their star by building massive structures around it, solar collectors, satellites, or even a sphere of orbiting platforms. Over time, such a civilization might envelop the star completely. If a portion of such a structure passed between us and the star, it would cause dips in brightness, deep, irregular, and non-repeating, just like those observed around Tabby's star. Proponents of this theory point out that all natural explanations, dust, comets, planetary destruction, have fallen short. But the light curve observed by Kepler is exactly what we might expect if large geometric objects were orbiting the star. Additionally, the lack of infrared radiation is consistent with a hypothetical megastructure that's absorbing and re-radiating heat in non-visible wavelengths, perhaps intentionally directed away from Earth. The absence of radio signals might suggest the builders are silent or not interested in being found. The idea gained serious attention when Jason Wright, an astronomer at Penn State University, cautiously suggested that Tabby's star deserved to be a SETI target, one of the few times a known star has been proposed for active investigation by the search for extraterrestrial intelligence. SETI's Allen Telescope Array and the Green Bank Telescope both observed the star for unusual radio emissions. Nothing was found. Skeptics, and most scientists, remain cautious. As the saying goes, extraordinary claims require extraordinary evidence. There is no direct proof of alien technology here, only a lack of satisfactory natural explanations. Even Dr. Tabitha Boyajian, who led the initial Kepler analysis, said, "We don't say it's aliens, but we can't rule it out." To this day, the Dyson Sphere hypothesis remains on the table. Not because it's proven, but because so far everything else has been disproven or remains incomplete. Whether Tabby's star is natural, artificial, or something else entirely, it reminds us of one thing. The universe is bigger, stranger, and more wonderful than we can yet explain. And sometimes, asking the wildest questions is exactly how science moves forward. Let's pause and reflect. We've journeyed through 5 fascinating theories, each one offering a different window into the mystery of Tabby's star. From icy comet swarms and cosmic dust clouds to the mind-bending idea of an alien megastructure, this single star has challenged how we understand the universe. So what have we learned? We've learned that even with our most advanced telescopes and decades of astrophysical knowledge, the cosmos still holds secrets that resist explanation. We've seen how science doesn't leap to conclusions. It explores every angle. And even when the data doesn't offer clear answers, the search continues. It's this pursuit, this willingness to say, "We don't know yet," that drives astronomy forward. Tabby's star isn't just a puzzle. It's a reminder that we're still beginners in a vast, ancient cosmos. So here's the big question for you. If one star, just one star out of hundreds of billions, can defy everything we thought we knew, what else might be out there? What other anomalies have we missed? And are we truly ready for the answers? Drop your thoughts in the comments below. Do you believe Tabby's star is hiding something unnatural? Which theory makes the most sense to you? 1, 2, or maybe something we haven't even imagined yet? And if this journey into cosmic mystery sparked your curiosity, We've got more for you. Click on the video appearing on screen now to explore another space anomaly that scientists still can't explain. Don't forget to like, subscribe, and turn on the notification bell so you never miss a moment from the universe's strangest frontier. Until next time, keep looking up. The universe is watching. End of script.